Welcome back to Nature of Code in Rust and GGEZ. Today we're going to be going over example 1.10, accelerating towards the mouse. So in the last exercise we created this, which when we run it, it's a ball that accelerates randomly in the direction that Perlin noise takes it. So this time, we're going to be grabbing the location of the mouse, grabbing the current location of the ball, and then creating a force that's going to be used, to steer the ball. So we can see that it's moving towards the mouse wherever I put it. And we can see the instructions here. We basically are going to create a direction vector, normalize that direction vector, scale it, and then set it to be the acceleration. So let's go ahead and do that here. So we have our mover, and in update, here's where we're getting like the Perlin noise and everything else. I don't think we need any of this. So I'm going to go ahead and just remove Perlin completely. So that means we have our location, velocity, acceleration, the mesh, and our top speed, which I think is fine. So we'll get rid of all of these and remove you as well. Okay, so this should be good. Now in update, we don't need to do any of this stuff anymore. We're just going to have our acceleration. Now acceleration, you are just, well, X and Y doesn't really exist, do we? So here's where we need to figure out what our mouse, well, we know where we are. We need to figure out where the mouse is. And based upon that, then we're gonna move in that direction. So let's actually take in a context here. Mute context, and we can get the mouse position. Let mouse equals mouse location. We pass it in a context. We can actually, we don't even need to return a result. That just gives us a mouse, which is a vector 2. Perfect. All right, so then we need to take our mouse, we need to get a direction. So let mute direction is going to be equal to, this is where we're going to take our mouse and subtract it from the location. So mouse minus self.location. That gives us a brand new vector to use. We're then going to normalize that. So direction.normalize. And then we're going to scale it up. Let's actually add our scale in here. So scale is going to be an F32. Let's use the same value that they have in a book, which is 0.5. And then, okay, after we normalize, we're going to say direction.multiply scalar by self.scale. And then we're going to set the acceleration to this, to the direction. So self.acceleration equals direction. And now we don't need to do this multiply scalar with the acceleration. Instead, at this point in time, we now take the acceleration and add it to the velocity, and everything else should sort of work out for us. Now we have some errors, mainly because inside of the main library, we now need to pass context into update. But that's it. We do have a couple warnings. We're not using any Perlin noise anymore, movers. Let's remove that. And that should be good for us. Let's go ahead and try this and see how it works out. Cargo run, and here we can see we have a ball that is constantly moving towards the mouse. And so that's example 1.10, accelerating towards the mouse in Rust and GGEZ. I look forward to seeing you in the next video. Thank you very much, and have a great day. Bye.